Nah, another draft physics video production. Almost forgot. I have to make the video, talk, and such. Alright, anyway, probably lots of subjects here. Anyway, have you ever done a video on magnetic damping or magnetic braking? Yes, but probably just part of the Professor Lewin videos. When I played those videos, the subject did come up. It's kind of, yeah, there's nuance to it, and I can't say I have every detail figured out about how. It's just this conduction argument, about the nature of moving electricity and the fact that electricity polarizes atoms. So when the atoms are moving the electricity, the pressure, they're making little, dipoles in the process and creating magnetism, the filtering effect. So it's converting regular atoms into essentially like an iron atom, a polarized atom. But yes, exactly how all of that ends up being a certain shape to the magnetism, a direction, all of that stuff, a density. So by my analogy, it would be creating mirrors, making something more of a mirror that reflects red than a mirror that reflects blue. And but anyway, I'll get to some pictures. I couldn't figure out how to correctly explain the following phenomenon with your particle model. Well, you can't explain it with any model in any simple way. So that's the catch, because it's more than one process, right? It's the process of the energy going into a system and then how the energy moves through the system, and it just kind of depends on how it moves. If you drop a magnet through a copper coil, that doesn't form a closed circuit. Only a small damping effect occurs, or none at all. If I close the circuit and drop the magnet through the coil again, now the damping effect will be greatly increased. Yes, so, and apparently the logic would dictate that because a current is flowing in a big loop. Yeah. Nighthawk in Light has a video demonstration of this, right? So I went to the video by its title. You can find it. It's a clear demonstration, not an explanation of anything, just a demonstration of something. Clearly the flow of current must change something about the configuration of the atoms in the copper wire that causes it to interact differently with the magnet. Well, I would say it's reacting the same, but the difference is you're getting more magnetism out of it. That is, the atoms you're polarizing are polarizing in the same direction, which is the effect you want. It's not so much, it doesn't do you any good if the current does this, right? If it's going all over the place and you're making the argument, well, I should draw that, right? I can draw that much. So all takes a certain amount of a coordination doing all this stuff. So the idea is that you're having a magnet. Now the real point will be is that you're going to move this thing with a, I could draw the whole magnet, but who cares? You're really just moving, for the sake of the argument, you're usually just using one pole of the magnet essentially to create the effect. And I'll just use something linear. I'll draw a coil later maybe. But anyway, and the idea is you're going to move it across a surface or towards a surface. Doesn't really matter which one you're doing. And the idea is there's going to be a repelling magnetism created here. So this is the magnet. So it's radiating is the theory of force. And that force is going to take a surface that was mixed. That is, it was, mirrors of blue and red configuration. And it's somehow going to turn them into this blue configuration. So the idea is the surface is this normally. And what's going to happen is now it's going to be more blue than red. And how fast you move the magnet is going to dictate how much of this you're going to get back, and a lot of factors. So that's why it's not just simple. You could argue that velocity has to do with voltage. The higher the velocity, the faster you move the magnet down, or the faster you move it across the surface, will increase the effect by making more of this stuff polarized, and therefore increasing the density of the polarization, which in a sense is increasing the voltage or the amount of pressure. So if you have lots of little things with pressure, lots of little containers of pressure, it's almost the same as increasing the pressure in one big thing. The two have a certain equality. In that it's all spatial. You have to, this thing's filthy. Anyway, so the idea is, the simple argument is this: when this blue stuff hits a blue thing, it reflects, and so that gives you this idea that it getting caught between the two things and constantly reflecting back and forth, and that's what we're looking for. Here's the effect. So the effect is you want to try to create as much blue mirror here so this energy stays here. You want to keep the energy here, going back and forth. You don't really want to lose the energy here, going through some circuit or whatever. You don't want the energy wasted doing something else. You want it stuck here. You want to keep as many of these things in here and as few in here as possible to magnify this effect. And the idea is you have to convert these little red bits into blue bits, and so that requires a piece of energy. That's the part that's going to be conductive. All right, so you're going to hit this and the one that's red, and you're going to convert it to a blue, but that means that it's connected to other things that it was equalized to. That is, it had equal pressure with its surroundings. So every time you affect one of these, you're affecting all of these. You're going to create a current, and since the pressure is going to migrate through all of those, it's going to start, the pressure is going to be dampened in the sense that it's going to want to turn back into a red, because it's going to connect to all these other pieces that are going to take that away. And so sort of what the eddy current is about is the movement of that current. Now you could argue that that could be the eddy current, or this could be the eddy current, or so a part of the argument is going to be is some of the effect is a consequence of how big a current, how wide that circle is, and how much time you're spending changing atoms way too far away from here, which doesn't do you much good. You want to maximize how many you're converting here, where it can affect this. So that's the basic idea. So the idea is you're just basically wanting to create a exposure where you maximize. The first thing you want to do is you want to just be lucky and hit blue, the ones that are already the right color. Oh great, they're the right color. Okay, so I can reflect off that, and so that energy is conserved. But the conversion, like I said, is sort of an absorption, so that one's going to be busy for a while doing something else. And so you want to try to create as much mirror. So there's two things you want to do, right? You want to reflect off a mirror, but you want to also get rid of all these little red bits in here. You want to get rid of the stuff that's not reflecting. And the way to do that is you have to first convert it. So there's a price you got to pay to convert the mirrors. And you really want to try to maximize how many you create, right? Because you want to have as many to reflect off of as possible. But the conversion isn't a reflection, we could argue. So you're not getting any benefit out of the conversion. So that's your dilemma, is that you don't want to waste any energy converting the ones you won't reflect off of. Okay, you want to convert the ones you're going to reflect off, which you would argue are the ones closest to the surface. So you don't want to spend too much time converting ones that you can't use. And when they're converted, it's this process of conversion, like I said, that's probably polarizing the atom. So now we're back to this argument that what's really happening is the atoms changing from this to, say, this. All right, so you have your proton in here, and you could argue that this is your negative atom and this is your positive atom. In the sense, one atom, you can see the proton better, one atom is blocking the proton. So you could just argue that that's your plus and your minus, and you're just, in the process of electricity is all of these atoms in their ideal state are all the same size. So they'll all convert to something that's similar. And so you're creating a disturbance in a field of similarness. So you're making one big. Well, that one big is connected to this atom over here, and it's connected to this atom over here. So it's going to be sharing pressure in any direction it's connected to another atom. And dampening that bias it has. So it's going to start losing its negativity or losing its positivity. That's what a conductor does. So that's why this happens in conductors, you could argue. Now, the question is direction and what exactly you're doing when you're exchanging is that you're, for a moment, creating little magnets. So if it goes this way, the magnet's oriented that way, right? I mean, you have a plus-minus magnet in this orientation. So, so that's so you create one going this way. Now, if the pressure goes down, then you create a magnet going this way, right? And if it goes this way, you create a magnet going that way. So you're polarizing depending on which way the current moves. So the idea is you want it to move primarily in one direction, and that is making magnets in this direction, so that you're always creating a north and a south that are going to be, in this case, opposite this magnet. So the magnet you want to create is this one. So it reflects against that one. So ideally you want the current to move this way, I would argue. So you're primarily creating magnets in one direction. So you could argue that if there was an eddy current to be created in here, the shape of the current you would want to create would have to be rectangular, in the sense that you want the current to go a long way this way, a very short distance this way, and a very long way this way. And that's sort of the ideal you're looking for. Yeah, okay. I think that's a good enough start. Now we'll read some more and then do some more drawing. So anyway, he's specifically, might as well get to it. Might as well. Alright, so this is the phenomenon in particular that we're talking about. And it's, it's just another variation on the same theme. So you have a coil. Alright. And you're going to drop the magnet through the coil. Alright, it doesn't matter. So if you drop it north end first or south end, right? So it's going to be dropped with that orientation. And the key to that is one side is pushing. They're both going to push. So if I go north side first, I'm going to push the electrons down. In a sense, I'm going to give them momentum in this direction. If I put it south end first, well, then I'm going to do the same thing to the protons, and they always do the inverse. If you push a proton that way, right? Okay, you're going to end up swinging the electrons up the other way. So it's always going to invert no matter which way you put it in. So all you're going to do is, if I drop it south end first, then this will be the minus side, and this will be the plus side. If I drop it the other way, it'll be the other way around. So that's all you're going to change in terms of polarity. Now the key is if I close this, so there's no polarization here, I have no voltage difference, and I just make a closed circuit. All right, you can sort of see that that's sort of the wrong rectangle, right? I mean, from the argument I just made, now you're going to end up creating the magnetism, in the wrong orientation, in the sense that you want these surfaces to become reflective. So you want the, let's see how to put it, the current flowing through the wire this way is going to take away more of the effect. Well, that's not the right way to say it either. All right, just never mind that part. The point is that we already know that if you drop a coil through here and you didn't close the circuit, you're going to get a voltage across these two. All right, so let's just stick with that for now. And you'd almost argue that this should be the configuration where the magnet slows down, because there's nowhere for the energy to escape. You know, it's not, you know, it's completely open. Now, obviously, some energy will escape through here. I mean, you have all that, whatever it's called, the blue energy, you know, that seeps through the atmosphere. But that requires kind of a high voltage to jump that gap. But you don't really know what kind of voltages you're creating. But anyway, you could just put in a little LED here, and it will make a light, and then the magnet will go through even faster. It'll go faster. It'll go the slowest through the coil when the coil's an easy circuit, when there's an easy way for the pressure to escape. And the harder I make it for the pressure to escape, the harder it is, the more effect I get out of the copper, okay, in terms of a reflection back. Right, so I ought to just stick with that. In a sense, you could sort of, so it's opposite of the intuition here. So I guess it's the only point to make is you're pushing, you got nowhere for the stuff to go. You could sort of understand it would push back, because everything would have to become very negative going forward. So as you're pushing this through, you're theoretically making all of the surfaces more blue, because you know, that would build up pressure, and there's nowhere for the pressure to go. That would be the intuition anyway. Well, anyway, so that's the real experiment. So let's continue with what he's saying. The actual blah, 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 blah. All right. Let's see. Clearly, the flow of current must change something about the configuration of the atoms in the copper wire. Yes, so the idea is you're making magnets. So that's what you always have to think about, is how are you making magnets when current's flowing through this wire? In the sense that are they going to be oriented in the right direction? Are they going to be, see, in this case, they all have to kind of, you want the little magnets to all be facing each other. That's the whole way a coil works, is by creating reflections. So the whole way you magnify, you know, the magnetic effect in a coil is to basically create all of those surfaces inside the coil. They all have their magnets facing each other, essentially. So the coil ends up causing reflections back and forth, and that's how it stores energy. A coil is basically a kind of battery. That's all what all inductors are, is they're storage units, essentially. They shoot energy, okay, as you run electricity through them, and that energy reflects back. And so this coil, in theory, would be, all the wires would be right next to each other, and they're basically creating an interior surface, okay, and the surfaces are all reflective, in the sense that they're all shooting this mostly negative magnetism. Now, obviously, it doesn't create a perfect magnetic surface. All you're doing is changing the percentages of red surface to blue surface. And any change is a change, right? So, I mean, you're just saying it starts off 50-50. I mean, the ground would be some state, but let's just say it's 50-50. And the magnetic effect, or the charge effect, just means that you've changed that proportion a little. So the little red bits are a little shorter, and the little blue, the amounts of blue is a little more. And any percentage change, it just means that you're preserving some more energy. You're going to create more blue in here. So the more I can change those mirrors, you know, to have a little bit more of a blue mirror than a little less red, I'm going to get more energy trapped in here. And so it's all still about just trapping, and you know, how the trap is how you maximize the how you create the ball between the two ping pong paddles and the fact that you have the capacity to make more pressure just by moving surfaces closer to each other. So once there's a ball between two ping pong paddles, I've sort of guaranteed that there's a point where, theoretically the pressure can go to infinity. All right, more electrons pushed to the surface. So yeah, how exactly, I would argue that physics hasn't really proven that electrons actually leave the atoms, that they actually move somewhere, that the electrons are actually going somewhere. The argument can be is that electrons aren't really moving anywhere except when you use an anode and a cathode and actually are shooting matter across. Then those are electrons. But this process isn't electrons. It's just the pressure and how the pressure changes the atoms it's moving between. So the electrons aren't necessarily going anywhere. The electrons push to the surface, just meaning that there's more atoms that have electron heavy, that don't have a balance between their electron and their proton. So I could just, I should draw it in the right colors just to make this not a mess. So what we're really talking about is we're going to create an imbalance in position in terms of this atom will now be polarized because one electron's closer to the nucleus than the other one. So one side is looking, let's say, north, and one side is looking like it's south, because there's a differential between the distances between the proton and the electron. And so that's the pressure differential that the next one will have to compensate for. Then if this one's closer to this one, then this one's going to be further away, and then this one's going to be closer, and then this one's going to be further away. That's the cascade of current. This will have to equalize, and as it equalizes, all right, you start to lose this polarity. So as this position becomes more where it's supposed to be, okay, the atom's essentially losing that disproportion. So you just, well, whatever. I think you get that. All right. More electrons, but actually I have some trouble understanding copper plate damping effects as well. As the magnet approaches, it changes the configuration of the surface atoms. Well, surface is kind of a tricky word, right? It's changing atoms going into the surface. And again, the key is which way is that conversion happening? Are you making magnets that are lining up with each other? Or are you making magnets that are going all kinds of ways? And so the more you herky-jerky the path, right? So if I go a straight line, I end up with north-south, north-south, north-south. So if the pressure moves in a nice straight line, I get nice north-south, north-south, north-south. If the pressure moves erratically, like a lightning bolt, it goes this way, and then it goes this way, and then it goes this way, and it's going this way, then I'm making a bunch of magnets that aren't in the same alignment, and we know what that causes. Okay, we know that ends up creating a dipole field, a mixed field, not even a dipole field, a mixed field. And so that's the difference between a piece of iron that's a magnet and a piece of iron that's not. And the difference is the one that's not has lots of magnets in it. Same number of little magnets, right? Same number of magnets. It's just that the ones in one thing are aligned and the magnets in the other thing are fighting against each other. The north-south's going this way in one, and the south-north is going this way in the other, and they're defeating each other's purpose. So we're just talking about the effect is being caused by maximizing the exposure to the force to create atoms that have the greatest consistency in terms of their orientation. You're trying to align whatever dipole you create, you're trying to ensure that your dipole goes the right way. So again, if it goes this way, then the dotted line, well, yeah, that's what I should use. I should just use a dotted line, and that'll show what I'm talking about. So I hate to erase this perfectly good coil, but always return him. So the idea is that if your flow of electricity is this way, then you're creating magnets that are essentially all lined up in the same direction. Jesus. I thought I got rid of the glare, damn it. Now it's coming off the window, I guess. I can't do much with that, except change the angle. So I have to block the window? That would really be irritating if I have to do that. I can't do a video when the sun's out. Irritating. Anyway, I have to hold it in this lousy position. So the idea is that you want the current to flow as straight. So that's sort of the argument here, is if you have a if you have a clear path for it to take, in the case of the coil, okay, that would be the clear path is you have a short, okay, so there's a clear direction that they're all going to line up because they're going to clearly move through there efficiently. And if you're blocking it and you don't have it, then there's an inefficiency because there's more pressure here and there's no clear path for the electricity, so it's going to do this kind of stuff. All right, so what we could clearly see here, if it's doing that kind of stuff, if it's not taking a clear path, well then the dotted line, okay, the magnets, you could sort of see will end up lining up in configurations that are completely destructive. All right, so the magnets will be lined up in ways that end up defeating their purpose. The red ends won't all be facing the same way. They'll be going, you'll be shooting red energy this way, and then you'll be shooting red this way, and you'll be shooting red this way, and you'll be doing the same with the blue, and they'll end up just mixing with each other and defeating each other's purpose. You won't be creating attracts. You won't be creating mirrors this way. You need the mirror surfaces to all be doing this kind of thing. You need them all to be this way in orientation. Mirrors facing that way or mirrors facing that way aren't going to do you any good. You want the mirrors this way, so when the energy comes in, it can reflect and reflect and reflect. If it's going this way, I can't reflect off that. I'm going to miss that. I'm not going to reflect off that. So it's really just about orientation, the orientation of the dipole magnets you're creating by putting pressure into them. So by making them big, by pushing pressure in, or small, you're effectively, okay, that's the best way to say it. Yeah, you're creating a dipole in the sense that if one side of the atom, it's really just, I don't want to get into the whole thing. You're really stretching. So when I say you're pushing pressure in, I suppose the argument is you're just changing, you're creating pressure on one side of the atom, the side you push the pressure into. So there's more pressure on one side, all right, or less pressure on one side. The pressure is either, you could even think of it as either the pressure is going in this side of the atom or the pressure is going in this side. So you're changing the orientation to the proton. I mean, I'm using red when I should be using blue, but based on shifting the electron's position. Are you moving this one closer to the proton, or are you moving this one further away from the proton? And that's the difference between the two polarizations, I suppose. Something like that. All right. Moving on. All right. All right. As the magnet approaches, it changes the configuration of the surface atoms depending on which pole is facing the plate. Right. So it's not only which pole is placing, what the pole is doing. What's really going to be important is what's the eddy current doing. Is the eddy current, the current, flowing straight to something, through something, or is it flowing, is the pressure being spread in straight lines, or is the pressure being spread in all kinds of directions that won't create, the mirrored surface won't be facing the right direction? Your mirror won't be facing back up at the thing that's hitting you. It's going to be facing in the direction the current's going. All right. I think that's kind of an 80% explanation. Like, that's pretty solid, that this really just has to do with maximizing mirrored surface. And the trick is that you can make mirrors, but you have to make the mirrors all facing the same way. Okay. As the magnet approaches, change the configuration of the surface atom depending on which pole is facing the magnet. Braking needs some ping-ponging of force bits in your model. Right. So the braking is being caused by the fact, and the braking really just means you're throwing the force back at something. So if something's moving across the surface, now, like I said, the wire is a little more complicated because we're talking about the surface of the wire, but obviously what I'm pointing out is the more straight the path is through the conductor of a coiled wire, the more reflection you're creating on the surface. That is, the more perfect the atoms are on the surface in terms of going. So through the surface of the wire, if we were looking into the wire, all right, when it's conducting electricity well, what it's doing is polarizing the surface. Right, so it's the blue end would be there, and the red ends are here, and all this is how it's spreading how it's moving the current, is by polarizing the atoms in this kind of configuration. So your surfaces are all looking the same. All right. Now, obviously the current's moving that way through. I mean, it's going through the wire this way, but it's making magnets this way. And that's why, if you put a compass needle around, you'll get, the same effect on all the mirror. It'll be equal. It's because these are red, blue, red, blue, red, blue, red, blue, red, blue, all the way around, facing the surface. And that's how it starts. Well, let's wait for that one. So you can have a magnet going. For every argument, you could just point out how, well, the magnets could be going this way, red, blue, across the surface. Okay, and this is the magnet. Or, as we know, the atoms have to line up, so the other atoms have to connect to this red, blue with a red, blue. So you have to think of these as Legos that have to connect a specific way, like dominoes or something, that you have with the little dots, and you have to match the numbers. Well, you have to match the colors, and it always has to be, the blue thing always has to be next to a red thing, and the red thing always has to be next to a blue thing. So you can have the next magnet could be here, facing out this way, and this next one could be here, facing out this way, but this is the magnet going this way. This isn't a magnet. Say this here is not a magnet. That's just a blue pole next to a red pole. This is the magnet. So this is the way the force is leaving. It's not leaving this way, okay, and this way. All right. To make the argument, there's the real atom and the real dipole, and then there's the sort of fake dipoles that you can create when you're connecting the atoms next to each other. But those are fake ones. Those aren't going to channel blue energy in this direction and red energy in that direction. This isn't doing the channeling thing. So it only goes in the direction of the poles, is which way the energy will be channeled. So the fake magnets aren't the real magnets. So in a conductor, the real magnets are facing this way, next to each other, and the current's going that way. Well, let's not even get into that. So I can't take on too much in one subject, or I'll start making egregious mistakes. All right. All right, braking needs some ping-ponging of force bits in your model, right, doesn't it? Yes. So, yes, you have to maximize the orientation of the dipoles you're creating. So the current's creating dipoles. Obviously the current's being created by force, but anyway, it's the idea of the current moving is an understanding that you're polarizing atoms as the current's moving, and you have to polarize them in the right orientation for you to get this mirror effect. Okay. Red side of the magnet approaching affects the surface of the electrons of the plate, and they stick to the magnet. All right. Again, I'm not going to argue about surface electrons. I don't think there are free electrons. Electrons are highly motivated to stay where they are attached to their proton. They're highly motivated to stay there, and if you make them leave, they're going to find somebody else to hang out with, leaving more photons exposed, more protons exposed. Again, the exposure just has to do with distance. I'll just make the argument again. You know, this, I can make this completely block this guy behind him. You know, distance can do that, and that's all I need is an effect, is to, you know, create an effect where this is further away from this, and that means you're going to see more of this. If I jiggle this back and forth in front of this, right, this is the powerful thing. If I do the opposite, obviously opposite. So distance is really, my argument would be distance has more to do with polarization than anything else. All right. Should have something to do with some electrons being only loosely bound in conductors. So again, the bounds of the electrons isn't really the subject. I'm just arguing that that's, yeah, conventional physics has notions of spinning things and all that kind of stuff. I'm saying it's just doing this, okay? This is what's happening. Okay, so, and the closer I make this, right, you could argue that now I've really made this strong because it's closer, you could almost argue, right? I mean, in theory, how much of this gets exposed is going to depend upon, you know, especially if this is oscillating, right, it's going to depend on how close, the closer it is, the more it's, you know, there's a point where you could say I can make it close enough where it's going to block everything. There's not going to be any of this showing ever. Or if it's out here, I have some chance of seeing this more often. That's where it gets complicated. I mean, there's physics here, simple physics, but I'm just saying it's a little bit complicated to figure out exactly, you know, without, you know, doing the experiments, which one creates more effect. But I'm just saying the idea that this is the nature of polarization, in the sense that this is the nature of how much light you're going to see from the blue thing and how much light you're going to see from the red thing. Clearly, that's affected by distance over some span, right? So we're talking about how much motion this has. Like in their theory, they're doing this kind of thing, right? It's a whole orbit. We don't need the whole orbit to get the effect. The more this oscillates, the slower it oscillates, the more this is seen, right? The faster this oscillates, the less of this is seen. All right, conductors. Even if you only get rid of a little of them, the surface will exhibit the net proton force, maybe. Yeah, well, like I said, the idea is just maximizing the energy's effect. So movement clearly exposes you to more stuff, okay, in the sense it makes more mirrors. The downside is you're using energies to make mirrors instead of reflecting off mirrors, but you need more mirrors. That's just a fact if you're going to create enough surface for the ping pong balls to be trapped between. You need as much surface of paddle to maximize this pressure effect, because the more surface of paddle you have, the more force you can collect in between it. Alright, so you push some loosely bound electrons of copper plate so much inward that they release some force bits they had trapped between themselves and the other electrons. You're not really releasing anything, you're just allowing the electrons to do their job, which is hate each other. And so the hate just migrates from the one atom you pressurized to the others. So again, it's just this fat, thin argument. The principle of the idea is you make an atom that's big, right? And it's next to an atom that's small. And the idea is these electrons, so the electrons are in blue in this case, will share their force with each other in the sense that their momentum, their jiggle rate, so they have a rate of jiggle. So when they get close to each other, they're jiggling. So that's the ping pong paddle moving like this. And if there's a paddle over here and a paddle over here, both of them are going to realize this jiggle thing, because it's going to create more pressure than less pressure, more pressure, less pressure, more pressure, less pressure. Right? So it's going to create this capacity for this pressure to essentially dampen, in the sense that it is going to meet an equal and opposite reaction, okay, a destructive interference, so to speak. And so the energy is end up going to be conveyed to this thing. It's going to make it more jiggly. And so this big pressure will be pushed into this pressure, causing this one to, let's just say, expand. I mean, it doesn't necessarily have to be expansion. I'm just saying that all it has to do really is with the jiggle rate. But anyway, that's how this pressure is being conveyed to this pressure, is because these electrons communicate with each other. Even if they're over here, even if this electron's over here, it's still communicating. So every electron in the vicinity, these electrons are communicating with. And the more direct the communication, obviously, the easier it is to transfer the pressure. And the more distant the communication, you're still going to sense all of that extra jiggling, and it's going to make you push away. So you're still going to absorb some of that pressure. So that's the equalization. So you change this atom by changing its electron. One paddle starts wobbling. The wobble moves into all the other paddles, and theoretically it dampens. That way it spreads to all of them. And if you have some way to go to ground, where you can just get rid of all the jiggle, then eventually you'll just dampen all the jiggle right into the ground, and they'll all go back to their normal rate. That's sort of the idea. So you can put momentum into one. That momentum will be transferred to every other atom in the vicinity. And if there's a place for it to eventually go, that is, there's something really, really quiet somewhere, well, the really quiet thing will keep eating all the extra jiggle, and eventually you'll have no extra jiggle, and you'll be equal to the ground state. That's the idea. I mean, I can only really do this in terms of generalities. And again, I'm not disputing, they don't really have math for that specific kind of transfer. They're only doing it in generalities too. They're only doing generalities. What's the average, and what's the average displacement of the potential in terms of how fast can that pressure move through the conductor, and all those things. And those are all time variant equations, and that decides how inductive the inductor is, and it decides how much capacitance the capacitor has. So, I mean, you can get really specific, and I'm not arguing with those specific statements about what a billion protons and electrons do inside a capacitor, but I'm just saying nobody's really dealing with what exactly happens between atom and atom, because there's atoms that are really close, and there's atoms that are far away, but they're all feeling each other's reality. They're all feeling each other's existence one way or another. The force is being transferred to them because of the fact that the electrons and the protons are attracted to this proton is attracting every electron everywhere. It's like gravity. Yes, it's a weak relationship at a distance, but it's a relationship, and it still exists. So, me saying it goes this way. Well, it doesn't really. It goes whatever the shortest path is, the most it's going to go through. So it's like water. Most of the water, if you just dump it, it'll go this way, but some of it will go that way, and it spreads. And obviously this would have some leakage. And I guess the real performance issue is that how much leakage can you get rid of? And maybe that's what superconductors are doing. It's just getting rid of all the leakage, and it goes in a very straight line, all of the pressure. it takes the straightest path, the shortest path, more efficiently. Okay, so I think that's probably it's okay if you got further questions, fine. If there's something that just doesn't quite fit for you, but I'm just saying it's really just about mirror making. First, you got to make the mirrors before you can reflect off of them, and the motion is key to making the mirrors. Exposing the force to as many surfaces as possible, and that's why the movement is so critical. All right. A virtual photon is a bookkeeping object. You can say that, but it really isn't, okay? They use a virtual photon for every communication of force in their atomic theory, okay? So it's creating the strong, weak forces. It's doing everything. Every effect is being created by some sort of virtual thing. And just as I just described, just as what I just showed, they're not giving you a force, okay? They're not saying what this thing is that communicates between the magnets. And I'm just saying, instead of a virtual force, I'm giving you a real force, okay? I'm explaining where the energy comes from. So you have this idea. Again, my blueprint is exactly Maxwell's blueprint. Maxwell wouldn't draw it any different than I'm going to draw it, explaining the basic force lines, okay? The lines of force, the thing that really is causing the effect. He's going to do it the same way, okay? He's going to explain to you this is a dipole, and it's very much like a charge in the sense that it's doing the same thing. This is radiating energy that will, and this is radiating energy, all right? And so they call these virtual photons, but they don't have any other explanation for where this comes from. This thing, this field that's moving the speed of light, right here, this stuff that Maxwell proved is moving the speed of light, or demonstrated, going from one place to another, and it's communicating with some other object. And so if Maxwell was to draw two charges, this is what he would draw. He would tell you this is the force lines, okay? And if you measure how close these lines are to each other, like from every point you have them come off this way in a random manner from any one location, so they're how close, how many of these little lines hit the different surfaces will tell you what kind of effect you're going to get off of this, and that creates these lines, which are a representation of how strong the field is. And so it's telling you what's your distance, how much blue stuff is getting here and how much red stuff is getting here. That's all it's telling you. And the fact is that when you line up little compasses, well, of course they're going to line up with the magnet in terms of the orientation is going to be consistent. So I drew that exactly the opposite way. Their orientation is going to be, the blue stuff is going to run away from the red. Oh, the other way around, asshole. Sorry. Yeah. I did it again. So, the reds are going to run away from the red because it's reflecting, and the blue is going to move towards the red because it's absorbing. It's absorbing blue force, or you can say it's absorbing the red force, either way you say it. But this is all this is. So don't tell me what a virtual photon is. I know what a virtual photon is, and it's not some fucking nothing. It's what they've created, like bent space. Instead of saying a real force is pulling or pushing things towards the earth, they made up a non-force, something they don't have to account for where it came from. I'm explaining to you that there's a bunch of energy in the universe, and this thing, all it's doing is filtering it. If a blue bit hits it, it reflects. Okay, and if a red bit hits it, it diverts. Okay, I'm giving you an explanation. There's a real force creating these lines. These lines aren't being created by nothing. And again, these lines exist in Maxwell's drawings. All right, it isn't about this swirly crap around that. There's nothing going, there's no evidence of anything moving in a direction around a magnet. No evidence whatsoever. Ever, ever, ever has anybody put a magnet somewhere and got something to move, okay, in that direction. It's not happen. It doesn't happen. It won't happen. Unless you put a magnet in there at the wrong angle and it flips, well, it's still not going to move in this path. All right, anyway. A virtual photon is a bookkeeping object to permit the conservation, sorry. To permit the conservation of energy. See, again, to permit, it doesn't permit it. You have to create energy before you have an effect. They create the energy. Yes, it's a closed system, so the same, like the gravity argument. You have to use the same amount of energy to leave as you got going in. But they never accounted for where the energy going in ever came from. So the fact that they're conserving it in the sense that, well, they're going to use it up to leave the gravity, oh, of course. But where did it come from in the first place? You have no origin for the cycle. I'm not saying you have a non-conservative cycle. No, the cycle's fine. You're not explaining where the energy came from. Stupid fuck. That's why it's called a virtual photon. They would call it a real photon if they could explain where it got into the system. Who made it? Did the magnet make the photon? Who made it? Where did it come from? So the fact is they can't account for its existence. It's like saying the sun is producing light, and yet there's no loss of mass and nothing changes. It just produces light for free. No one in physics would argue that. They'd say, no, you got to account for where the energy comes from. Light isn't free. You can't make free light. Shit. Oh, you people are just so full of shit. Anyway. To permit energy when an atom's electron shells are in a transitional state. Yes, due to photons. Magical photons undergoing motion from states ground and up. Yeah, I'm just saying you can't have free motion is the argument. The motion has to be caused by something. Something has to interact with it to create the effect. The atoms and molecules in my body do not accelerate through the earth, attempt to move down for no reason. Something is hitting them, something is pushing them, something is affecting them, and the virtual photon is the explanation in the case of magnetism. Now, they don't use a virtual photon for gravity because they use a bent geodesic, just some sort of magical thing for which my electrons and protons are just some kind sliding down the geodesic. They're on some water slide, which is just basically saying, right, a water slide only works because of gravity. So they're using gravity to explain gravity. I mean, it's bullshit. People are just so petty, stupid. Anyway, undergo motion from states ground and up. The theory may not be right. No, it's not about the theory being right. It doesn't account for where the source is. What's the source of the energy? I'm giving you a source of energy for magnetism. I'm basically telling you right to your face, there's this stuff, cosmic background radiation. Well, guess what? There's a whole bunch of it in ray form that we can't detect because it's gravity, you fucking dumb nuts. Okay, it's a real force and it's coming in mixed. And the magnet is basically filtering the mixture. It's basically going to say, you put in mixed stuff into me, I'm going to shoot the blue crap this way and the red crap that way. I'm going to segregate those two forces. I'm going to filter them for you. All right, that's where the energy to move the magnets comes from. It's coming from the exterior universe, and obviously every little bit of it's a piece of momentum, just like every little piece of light is a piece of momentum. And it has the same effect. It can move objects when you filter it. Shit. The theory may not be right. Yeah, obviously wrong in my opinion because there's no source. But it's curious to label such kinds of explanations dumbass. Well, it's dumbass not to realize that a bent geodesic is not a source of energy. Or a virtual photon is not a source of energy. Virtual gasoline, if I use that, you don't think it would be dumbass if I said to somebody, well, why don't you just pour some virtual gasoline in your car? You'd look at me like an asshole, right? Say, what the fuck are you talking about, virtual gasoline? I can't use no virtual gasoline. That's got to be made out of real shit. My car runs on real shit. It doesn't run on fake fucking virtual shit. Yeah, you're a dumbass. Okay, you've accepted a completely non-answer to a question. You ask a simple question, why do the fucking magnets move? And they give you a dumbass explanation. Well, virtual photons make it happen. Virtual gasoline. They're all running on virtual gasoline. Don't you get it? It's so simple. You just pour the virtual gasoline in, the car engine works. It does all of this stuff. It creates this red shit coming out of here, this blue shit coming out of here, and all this stuff comes out of here. And there's all kinds of hyperboloids and toroids and all kinds of spinning and bullshit. All on virtual gas. No real energy involved at all. You're a dumbass. Such an attitude means genuine scientific community will never engage with you. Well, the genuine scientific community is a bunch of religious kooks, right? That's my argument. So it's like saying, oh, the Catholic Church will never engage with you on this theory of evolution. Yeah, for obvious reasons. They're invested in bullshit. Okay, that's not my fault and it's not my problem. My only obligation as a logical human being is to tell you I have a theory that fucking works. I can explain how real gasoline makes real cars move. Okay, and if you want to keep believing in your fucking angels and your bullshit and your fairy tales, go right the fuck ahead. I can't stop you from being a goddamn fucking imbecile. And a bigoted one to boot. Okay, because you're basically saying if I don't follow the dress code, I can't play your game. You're an asshole then. You're an ignorant fucking asshole, and you're ignorant for the very reason because you just couldn't give a shit about the truth. You just want to hear about how you're magical and how you all got virtual fairy wings. Fuck you. While a virtual scientific community would simply look at your musings and conclude this guy's most probably a dumbass. Well, they can't do that if they really engage in debate, right? So I'm just saying that I think the argument can be made quite obviously and proven essentially that the scientific community is pansy. It will not argue even among themselves. The Copenhagen people sit there and play little respect games with the string theory and the multiverse. Oh yes, well that's possible. Maybe if I take some drugs and wipe my neurons out and become completely illogical, I could believe your bullshit. But yeah, it sounds like bullshit to me. They're afraid to even say that to each other. They're fucking pussies. And clearly, what do? You can see it all over the place with the scientific community. Go find the dumbest retard on earth and go have an argument with him. They're chickens. They're pussies. They're fairies. They're wusses. They're cowardly douchebags, okay, who don't want to have a real argument about how bad their physics is. And they avoid it all over the place. They give each other Nobel Prizes for making shit up. Oh, matter, we can turn matter into special virtual energy. It doesn't have to be real energy. It can just be vibrations in some sort of space bullshit, time bullshit that wasn't supposed to be energy, right? Your bent geodesic is not supposed to be energy. It's not supposed to be actually pushing things, right? But then when you want it to, all of a sudden you convert matter, not into energy, as Einstein says you can, no, but into some kind of bent geodesic, into a virtual thing. I mean, fuck you. Does it ever occur to you that maybe he's a fraud who relies on audiences having little or no knowledge of things? So again, these people can't make a single counter argument. They can't show how this theory doesn't work or how it's mechanically too complicated. I mean, 2 + 2 + 2 physics. I've cut it down to so simple. And they can't even defeat it. They can't touch it. I made it so simple for them, and yet they can't touch it with a rational argument. They can't explain in one way how it doesn't fit the evidence. They can't show me an experiment that it fails to explain. They just do this bullshit. Relies on audiences having little or no knowledge of things like Maxwell's equations. Number one, they're not Maxwell's equations, right? They're Ampere's equations and Gauss's equations and lots of other people's equations. And number two, if you really cut it down, there's no wave function anywhere to be found. There's just sine fucking theta. There's a change in angle. And as Feynman pointed out, it comes in fucking clumps. It's not a fucking wave. He said it right to your fucking idiotic, moronic faces. Okay, and he basically described in his Feynman diagrams exactly what I'm saying. Okay, you hit an electron with a photon, the electron changes its position and its orientation and its momentum, and the photon released will be at a new angle. Period. That's the answer, dumbasses, fuckheads, retards, shit for brains. So fuck you in this bullshit. I'll just delete this one, but give him another shot. But John, yeah, go fuck yourself. There's no inconsistency with this theory and Maxwell's equation. So again, this is their big lie, that somehow Maxwell says something other than this happens. when Maxwell drew these fucking lines of force, when Gauss's math is really just about exactly the square being created by these lines of force. Gauss didn't give a shit about this swirly crap over here, or this swirly crap over here. He gave a shit about these straight fucking rays coming off of the object. How many rays intersect the surface? That's Gauss's law, you stupid shits. Jeez. Oh, another long one. That won't let it scare me too much. Have you ever done a video on Oh, I already did that. So, sorry. My bad. Seems to make sense. Well, good. I'm glad it seems that way. Hopefully you'll think about it harder and realize that, no, it's more than a seam. But anyway, what does decay have to do with rotations? Okay? So this is, I'm using analogies, and sometimes you have to just understand that yes, it's just an analogy for the way something behaves. Okay, so making these specific crap little arguments are just kind of irritating. But anyway, what's the rotating part? The rotating part is always going to be the force, fundamentally. Right, and we're just talking about sizes of traps. So again, it's just like the previous argument. It's the movement of the force, the pressure, that decides whether you're making magnets that are oriented with each other or magnets that aren't oriented with each other. And the same is true in, say, radioactive decay. Okay, the decay would be between the rotation that, say, is built into a big atom that has a lot of parts. All right, we have this idea that over time it's degrading. That is the nucleus. So let's just say this is a nucleus. We'll just put a bunch of crap in here. And the assumption is that it's the nucleus that decays. All right. So it's got all these parts to it. Well, the parts that are where the rotation is happening is the rotation between these elements, okay, the electrons and the protons. And it's essentially a rotation in the sense that, let's say you reflected here and you're reflected here, right? Well, if you keep going back and forth doing that, you could sort of get the idea that that's a circle, right? I mean, it's in theory the same thing, right? If I go back and forth this way and this way and this way and this way, well, it's the same thing as going around this way. And so if I lengthen that cup and I make it a bigger cup to have to go back and forth in, it's the same thing as just making the circle less round. All right? And I start making it longer and longer and longer. So it's the same precession argument. So it's the force that ends up precessing with motion, right? The force is moving the speed of light. All the little bits are moving the speed of light inside of here. And if I move the whole object with a momentum, well, that obviously means that some of this speed of light in this direction is moot, okay, in terms of distance covered, because the whole object is moving in that direction. So you can sort of see where, oh, you're cutting this part of the speed of light really off, and you're maximizing the effect in this direction, right? The opposite direction, you not only have this speed, but you have the speed of light this way. So this one has a bigger component that is more distance. But I mean, that's kind of a specifically technical argument. The idea that you could understand is the idea of just this idea that you have a certain balance in your force or your motion, your total motion, and that if I'm forcing you to move in a direction, that balance is going to be affected by the motion. I mean, it's something we see in our everyday life. If I take a water balloon and I attempt to roll it, right, you can see it turns into a tire tread. I mean, it gets longer. Now, the theory here would be it's not necessarily going to get smaller, this way. It's just going to get longer and stay this same height. So that's more distance. All right. I instantly imagine an electron in a planetary atomic model. Well, quit doing that, because that's really not these bits aren't doing all of that crap. Yeah, the force is trapped between them. So the force moves from here to here to here. The force moves from here to here to here to here. the force moves back and forth between two ping pong paddles. Again, if I just put two ping pong paddles here in a theoretical empty space, right, in space, no gravity, no other things affecting it, just two paddles, and then I throw a ping pong ball and hit this one, and now the ball's trapped between the two, you can sort of understand that I've just given that whole system motion. You can sort of understand that, right, if the two paddles were tied to each other. I've now trapped the energy, but it has motion in a direction. All right. But in accordance with your model, there's no inherent rotation in atoms. Right, the rotation is in the movement of the force between them. In it, electrons should be stationary. Well, it's pointed out nothing's stationary, and I certainly pointed out electrons are never stationary based on this whole odd number theory. You know, that they're always got to move somewhere because there's always never a perfect balance between their momentum in this direction, their momentum in this direction, their momentum in this direction, this direction, this direction. Say if they have 24 registers inside of them, or 25, they're an odd number. The point would be is what would the odds are? They have 7 going this way and 7 going that way and 7 this way and 7 that. You know, the odds would be 1,000,000 to 1, 1,000,000 to 1. That they'd have exactly stored no momentum. You know, a complete balance. Exactly as much stuff is hitting them from one side as the other side all the time. That would never happen. All right, anyway. In it, electrons should be stationary relative to the nucleus, like the iron filings falling in place around a magnet. They are. And the force moving between those iron filings and the other magnet is what we're really talking about. What's that force doing? Oh yeah, that force is moving all the time. And moving back and forth is essentially the same thing as moving in a circle. It's being trapped. All right. So what, and the only thing keeping the iron filings where you can see them, the fact is the iron filings are being pushed towards the magnet. They just can't get there because you put a piece of paper in the way and caused friction. So they can't get through the paper to get to the magnet. But that's where they want to go. And they're being pushed by a force that's now imbalanced. All right. So what circles are being prolonged? The distance the force has to travel is being prolonged. It has to, if it's going this way and then this way and then this way and then this way. And again, if I move those objects, it's going to have to travel more distance to make one rotation. All right, is it something that only happens in radioactive matter? No, it happens everywhere. But the point is this whole idea of this, they did this whole, we've proven Einstein's theory based on the decay rate of atoms. They said, oh, here's a clock that doesn't break. No, it's just another clock that breaks. Okay, you move the radioactive material and you break its decay rate. It decays at a different rate because you're moving it. All right, and the movement causes distortion in the positions of these objects and makes it more likely to decay or less likely to decay in the case of slowing clocks down. Is it something that can only happen in radioactive matter? No, it can happen to any, you can break any clock except for the light clock. But the trick is you can't make a light clock. All right, it's a hard job dealing with idiots. Yeah, well, I'm finding it impossible so far. It's not just hard, it's impossible. What if light speed multiplies by 10 over and over again? What if what? Light is made out of turkey wings. I mean, it's just, why speculate on nonsense? There's a million ways that you could deduce it can't be true, because there's a million ways to demonstrate that there's no faster than light communication. So fast that the matter of the small fraction of a second comes and goes to the edge of the universe. Yeah, whatever. What if? What if stupid, irrational nonsense had something to do with anything? Well, it doesn't. This is what really is happening. That is why there is spooky things. There's no spooky things in evidence. There's only spooky things in people's stories, okay? There's only spooks in silly stories. There's no spooks in actual photographs, okay? Or actual evidence, there's no spooky action. By actual evidence. All right, physics like atom that looks like it's two places at the same time. Well, there's no evidence of any atom that looks like it's in two places at the same time. There's no experiment showing me two atoms in the same place at the same time. So that's all horse shit. That's all storytelling. Energy goes in and out way too fast and acts as a band that goes. Well, I don't even know why you're doing this. Why? Why do you want to do something completely stupid like pretend you can believe there's something going faster than light, or that light is going faster than light? I mean, it's just silly because there'd be evidence of it, jackass, and there is none. Oh, I don't know why people are this stupid. Okay, wrong one. I gotta get rid of this guy, Specco. Some sort of foreign shit. Yeah, sorry. I don't have much patience for foreign shit anymore. Way too much of it. It's just all over the place, this foreign shit. Foreign shit used to be foreign, you know, way over there. Now foreign shit is everywhere, just all over the place. You can't step on the road without stepping in some fucking foreign shit. Alright. Yes, how dare people not believe in random guy's pet theory? Well, everybody was a random guy, so you could argue, oh, Einstein was random. Everybody was random. That's how everybody starts life, as being random guy, idiot. Okay, with no actual evidence whatsoever. So the actual evidence is the model works. So again, all I can do is build you a model, show it to you, and say it works. That's my job. Okay, Einstein's model was invisible force makes everything happen. Okay, quantum mechanics model was virtual force makes everything happen. And they still don't even explain how the virtual force does it. Virtual force sometimes is attractive and sometimes is repulsive for reasons unknown, for reasons we can't explain. That's what they gave you as a model. That's what you're defending this aggressively. You're defending a non-explanation. I gave you an explanation. This is why it happens. There's nothing wrong with it. Nothing you can point out specifically wrong with it, and yet you say it's not evidence. No, the model works. I've demonstrated. I've drawn you pictures of it working. Fuck you. There's no evidence whatsoever. There's better evidence than you ever got from Einstein. Better evidence than you get from quantum mechanics. Show me the quantum mechanics drawing of how magnets repel and attract. Show me their drawing, please. You're the one with the blind faith. So again, my faith is based on the fact that it logically works, it's simple, and it's complete. It explains gravity, magnetism, electricity, all of it. Just like the countless other cranks with their own pet theories. So he wouldn't type the word crank? None of you can create a model. Yeah, I've done that, asshole. Illustrated it with unique predictions. Well, of course, I've already made predictions. There is no gravitational lensing. It's a big fat lie. There are no gravitational waves. You're never going to prove that your waves are real in any sense because it's a horseshit theory made out of complete rubbish. There's no mechanics for it. There's no mechanics for taking a piece of matter, atoms, electrons, neutrons, turning them into some magical bent geodesic. There's no model for that whatsoever. There's absolutely no possible way I can draw electrons and protons and then explain how I turn them into a bent geodesic. Can't happen, shithead. Alright, and let's see. None of you can create a model with unique predictions or mathematics. Well, there is sort of mathematics built into it, but obviously I'm not disputing mathematics. I'm saying that, yes, well, I would argue with Einstein that the nature of the relationship between energy and mass has to do with the fact that the electrons already have a mass, okay, in the sense that they already have energy trapped inside of them. But you'll never get to that. You're not going to break electrons and get their energy. So the equation goes a little deeper than just the relationship between the forces that are trapped between the objects you've brought close together. All right. Nothing to actually be falsified or verified. Well, I'm telling you quite obviously, yes, I'm saying that in the radar experiment there is no wave interference, it's just jamming. Can be proven. The photons in the double slit experiment, I've explained to you how, well, with the multi-slit it's sending images to the locations. You can't use randomness and wave destruction, constructive and destructive interference bullshit. You can't create a projection of an image doing that. Make a projector that uses destructive and constructive interference, and guess what? It won't project the movie very well. Okay, and it certainly won't do it with any notion of randomness. It doesn't matter which photon hits the lens where. I can just randomize them, and somehow I'm going to get the right image in the end. No, you're not, asshole. Not even going to come close to being the truth. Your theory is shit. I've demonstrated the stupid holes in it, and I've demonstrated how it doesn't say anything, and you haven't drawn a single picture of it. You got a picture of nothing. Maxwell's pictures look more like my theory than your theory by a long shot. All right. Nothing to be falsified or verified. Well, of course there is lots, as pointed out. You've never verified. You never redid Eddington's experiment. You had a perfect eclipse over North America. You have 20,000, 25,000 satellites in space that have really good cameras on them. You haven't used one of them to prove Eddington's experiment, to redo it. It's supposed to be the foundation of your science, is verification through redundancy, through doing the experiment more than once. You haven't successfully done it again. Just the same old crude drawings and empty assertions. They're not empty assertions, they're direct assertions. Your lensing math doesn't make any sense. The fucking lens is the wrong fucking shape. Why don't you explain to me how a lens that's the wrong fucking shape, okay, that bends the light a lot in the center, okay, and very little at the edges, is the same as this lens. How is this lens the same as this lens in terms of creating a magnification, that is collecting light over the whole surface of the lens and focusing it to a single focus? Explain to me exactly how this fucking piece of shit lens does that. How does this lens take stuff that's going diverging from a center, okay, and it's actually going to bend it less? That is, it's not going to bend it at all out here, all right? It's going to bend it less, and it's going to bend it the most here. So the stuff that actually had a chance to make it to me, going straight line, that stuff doesn't even have a chance to get to my fucking eyeball. So why don't you explain how this fucking idiotic wrong-shaped lens can fucking goddamn collect light photons, collect them over a large lens, okay, and work. It can't work. It's a piece of shit as a theory, fucktard. All right. Here's my prediction. That is never going to go anywhere. Good. Why don't you put your real name on it? Okay, making predictions as an anonymous, cowardly asshole doesn't really mean anything. Let's have a name so I can humiliate your grandchildren with the fact that, look what a big fucking idiot your granddaddy was. He was such a dumb fucking naysaying moron. He might as well just have a little funny hat on and be some sort of pilgrim bigot with his little Bible walking around, how nobody can threaten his Bible. Why don't you burn some witches, you fucking archaic piece of shit? Ever. You will never get beyond where you are now, says you. And when I prove you wrong, where can I beat you with a stick? Drawing circles and arrows and updating your website. No one looks. Yeah, and those are all facts that condemn you. They're not a condemnation of me. They're a condemnation of you, the bigots. Okay, the cowards who can't show up in this room to answer my questions. You're an authority. Well, why don't you answer some of my fucking questions, you fucking authority? Throwing out insults. No, you're the one throwing out insults. There's no physics argument in your whole commentary here, is there? Lots of physics arguments. I just made a physics argument, shit for brain. In your rambly videos. Yes, all videos are rambly. So yes, so let's just say that to every person who ever made a video in the history of mankind. Wow, what a great argument that is. And blocking people who dare to... No, blocking people who are rude and stupid and liars. Right? And that's all you've done here. You haven't made any real assertion. You've said, I didn't provide evidence. I didn't do this. I didn't do that. I've done all of that. Okay, blocking people who dare to question your immensely delusional wisdom. Well, again, you didn't question it with any kind of counter argument. How am I wrong to appreciate the fact that, you know, even if you say this lensing thing only happens right there on the little far edge and there's just a little bit of lens, we're only going to use a little tiny bit of the gravity lens. It still can't project you a rational order of the object because the bending is happening in the wrong direction. Anyway. This is a prediction that is actually going to be verified. I can guarantee. Mr. Nobody can guarantee. Isn't that just amazing? The coward, the fucking screaming coward is guaranteeing something. Wow. I mean, that's like some psychic not giving us his name and doing his psychic predictions. And whoa, 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 whoa. Wouldn't that be so credible? You just make up a new name every day and make new predictions. And the day you actually get something right, you'll say, look, that's the only prediction I ever made. And look, it was right. Fuck you, coward. God, people are just so easy to hate. Okay, so that's his other comment. So you got 3 thumbs up from what, himself? Ugh, disgusting. So again, you people can't make a fucking argument. Weak ass shit. Alright, Ken Wheeler video. Funny. Just how obsessed can you be over a guy who just posts his opinions online? So again, is that all that anybody's ever doing? So you would never have argued. If Adolf Hitler lived today, you'd go ahead and let him talk his propaganda. You know, just steam up a bunch of people about how the Jews are out to get us and all that kind of shit, and that'd be just fine with you, right? Fuck you. You wouldn't counter-argue any of it, right? Fuck you. Alright, the fraction of people who watch Ken's videos for his metaphysics is tiny. Why don't you prove that to me, okay? I'd feel a lot better if you could prove that to me. Prove to me that that's what they're doing. So how are you going to do that? The videos get a bunch of views. They get a bunch of comments. People are obviously saying, please, more videos on physics, Ken. Please, 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 please. So, I mean, you're making an assertion that just, frankly, can't be right. Okay? I mean, the evidence is kind of overwhelming that it's wrong. It's not a tiny fraction of his viewers. At least half of them. Yet you're still obsessed over him. I'm not obsessed. I'm disturbed by everything on the internet that's garbage. And his is such extraordinarily bad science. And the fact that people are gullible enough to fall for that hyperberloid tripola, like he's influential or something. So again, that's, you don't think he's influential. He's got 1 million, 100,000, over 200, maybe 200,000 subscribers. His videos get, 10, 15,000 views numbers, and you're saying it's not a threat. I think it's a threat. So pathetic. Unlike you, he doesn't try to debunk. Oh, well, yeah, he's a coward. Guess what? That's the real job, is for you to debunk the physics. If you're going to make accusations, he only makes accusations against dead people. He won't take on a living person because he's a fucking coward. An uninfluential guy who likes to post his opinions on physics. You. No, I don't like to post my opinions on physics. I'm obviously arguing, idiot. This isn't about something you like doing. I don't like having to explain to you you're a dumb fuck, a dumb bigoted fuck. Okay, that, can't do the simple 2 + 2 + 2 mathematics is over your fucking goddamn head. The fact that you idiots can't even understand what you're supposed to be looking for, what the truth should look like. Well, guess what? The truth should look complete and it should look simple. Because the thing that made it wasn't a fucking god, you idiot. Alright, just get over him. Fuck you. I'm well over him. I mean, again, this is so fucking idiotic. You make one video, that would probably be too many for these people. So Ken Wheeler can just keep making videos lying about bending photons and doing all kinds of things he's never done, and that's okay with you. It's good to have liars in the world making videos, and nobody should complain about them. One video would be enough for your audience to get a sense of your feelings towards him. So the subject of physics you can just handle with one video. Fuck you. Yet you go on and on about him. Volume 6, huh? No, there's more than that. I've done probably 50 or 60 videos to Ken Wheeler. But so what? I've made over 1,000 videos, asshole. Ken may be touched in the head a little. No, what he says, first, again, he's a liar because he knows that he could just look under a magnifying a microscope and he could see what the little ferro bits are doing. You can see them under a microscope. You can see exactly where they're moving. He knows that, doesn't he? So why is he lying about what they're doing? But at least he's not a weirdo stalker, well, whatever the type, whatever this is. I've never stalked anybody. I'm done reading. Yeah, fuck you. Get hit by a truck as soon as possible. Get what you deserve in life, and that's what you deserve. You're a reckless talking dumbass, and you're not going to do the planet any good. My prediction. The sooner you're dead, the better off the world will be. Fuck you. So, done. Okay. So, till the next time, and such. So forth and whatnot.